Sky is so high, if you don't know how to fly, Aimfill is here to make you fly. Sky is so high, if you don't know how to fly, Aimfill is here to make you fly. Here we go.
System that is from it is the flight plan of Etihad Airways. So I'm having this from I just have one
Rise
piece
over
of
the sky.
Etihad Airways
Say it just
flight
in his
plan.
eye.
Going through those flight
Hold your heads
plans,
high.
I'll
Here we
give
go.
a brief detail about that. Now continuing with the topic, our next instrument will be the HFRTF, that is called the high frequency radio telephone, which is mainly used during oceanic flights. So these kind of equipments will be used for flights that has ETOPS, that is flying through water, and they don't have an that is they can't contact any ATC tower. So for those types of aircrafts which is traveling towards that is traveling above the ocean for a very longer time. So for those kind of aircraft, these equipments will be installed, and they'll be working. That is, their communication will be carried out using these equipments. Next, we have inertial navigation system. This is a navigation aid that uses a computer motion sensor that is called as accelerometers and rotation sensor, that gyroscopes, to continuously calculate the position, orientation, and velocity of a plane. So what this inertial navigation does is it measures the aircraft's movement, that is whether it's turning or not. Rotation senses the side of direction, and then the speed and its speed and which angle it's traveling to. So based on these, they create a navigational system. They send the information to the ground-based or sea-based beacons, and they get the response regarding that. So when I show you the complete flight plan, you will understand what actually these navigational systems or these equipments do. So next we have CPDLC. So that's a controller pilot data link communication. So it's a system installed in the cockpit where captains use this to communicate with the ground staff, that is the headset operator. He uses to contact to the ATC. He can use this to contact to the main base where the flight dispatcher has, that is if it's a flight plan way station, then he can contact to the dispatcher, he can contact to the ground service team. So there's a certain frequency. I'll show you that in the flight plan. So just keep this thing in mind. CPDLC is a controller pilot data link communication. Based on this, you can have your communications. Normally, all aircrafts have this CPDLC. That is, after the 1985s and 1980s, once the 320 series came in, the almost all aircrafts have this data link communication with them. So they do the messages transfer or message communication all through these data links. This is also same CPDLC, but another changes, it's have high frequency detailing. So this can also be helpful in communicating of longer distance. Say, for example, as I said you earlier, the CPDLC is used to contact the dispatcher. So if the aircraft is somewhere here in India and the base of the aircraft is somewhere in Abu Dhabi, he can still contact. That's a satellite high frequency data link. So he'll be able to contact the dispatcher who's in the base and help him out in situations. These are the normal data links that captains use in case of the aircraft goes grounded, or if he needs extra support regarding the weather conditions of the destination station. CPDLC fans 1/A VDL mode A. Same VHV data link, but this include air traffic control clearance, pilot request, and position reporting. This typically operates over satellite communication. It's mostly used in oceanic airspace. So these kind of almost after the first set, that is after the code GNSS, most of the all equipments that you'll be seeing is only for the oceanic that is oceanic airspace. You know that most of the aircrafts, if you leave the domestic side, most of the international aircrafts have to travel through over ocean. So for them, these kind of equipments are installed, and they are commonly using this throughout all the stations. Even though they have other facilities, the most common will be these CPDLC related equipments. This one also same. The report and the type of the method it works will be the same. These are all part of the CPDLC with different mode variation. That is, few will be having high data, that is long data variation. Some has very high frequency. So based on the distance that they are coming from the base, such type of equipments are used. You can see that most only a few number. If you watch carefully, if you're when you're working in the airport, if you watch carefully, you can see that a particular airline will set a set of aircrafts only to your station. Not all aircrafts comes to your station. A set of aircraft depends upon the frequency range. A set of aircrafts only come to a particular sector. That is, the main reason is the equipments they have for that. So for that particular sector, if they have this kind of CPLC fans, maybe mode 2 or mode 1, or maybe fans 1/8. So when these kind of equipment aircraft comes here, it's easy for the captain to handle it. Or else, if they don't have any required aircrafts to come for the station, they'll send some other aircrafts, and they need some other equipments extra to be added on to it before they send the aircraft to the destination center. So when you go to the airport side, when you work in your field, you will get to know why certain number of aircrafts or maybe certain registration of aircraft come to a particular sector, and not all aircrafts are coming there. Another CPDLC fans one, but this is SATCOM. This is also a satellite communication. The work process is different. Only the satellite network, that is the network they are going to use Inmarsat. So particularly on this satellite basis, these CPDLC works will be carried out. So this MTSAT. So each satellite has different variations. So based on that, maybe MTSAT will be in somewhere on the western side, and that is Western Hemisphere, and the InmateSat will be somewhere on the Eastern Hemisphere. So based on the satellite position, such codes will be used. This will be only for the sector that is from the base sector, and you need not learn too much about when you're going as an arrival sector for that. Here also we have something called Iridium, part of the SATCOM only, but here this indicator specifies that data is transiting via the Iridium satellite network. So each satellite network's name will show the difference. That is, the position of those satellite will allow these flights to take that particular direction. Maybe once the aircraft from New York to London is going with Iridium, the next time it can't be the Iridium traveling. It may be the previous one, the MTSat, or maybe it could be the Inmarsat. So it depends upon the position of the satellite that this kind of systemed aircrafts will be sent there. So that is all the engineer's point of view. Only you need to know what kind of system is that particular aircraft, that you will get the information from the engineering side. Next, MLS, that is a microwave landing system. It's an aviation approach and landing system providing most accurate and reliable information for safe landings. This system overcomes the possible limitations of the ILS. Something one step more than the instrument landing system, the advanced version of the ILS. ILS, the ground-based instrument approach system that provides precision guidance to an aircraft approaching and landing. I think ILS is common to all because that's the frequent word that we are hearing during the landing, instrument landing system. So it could be a ground-based instrument approach that will be kept at the touchdown point, that is the zebra line of the runway. So that is the point where the instrument landing system will be kept, and from that the radiation will be sent to the aircraft, which will help the aircraft to calculate the distance and the level of the runway. Next, ATC SATWISE Inmarsat. Same thing, air traffic control, radio telephone satellite communication with data transiting via the Inmarsat satellites. So this This one is not from the CPDLC, that is the Commander Pilot Data Link. It's from the air traffic control. Air traffic controls radio telephone satellite, and based on that, the transmission is done through Inmarsat satellite. Here, same thing, but with MPSat. We'll have Iridium for this also. So ATC Satvoice has also the connection with these three satellites, and so is the CPDLC. So most of the connections and talkings and communications will be carried out through these satellites, which is much safer and confidential. Next, VOR, that is very high frequency omnidirectional range, used for radio navigation system for aircraft. So radio navigation system based on this is one of the most common used because it's easy to communicate with the ATC tower. They'll have radio waves. Taking satellites is safer side, means the fastest way to send messages is through radio navigation. Next, we have the PBN approved. So in this, I think we have another two more approved navigation systems. First one will be the PBN, in which levels that can be met and is used by ATC for clearance and routing purposes. The insertion of R in the field 10A requires PBN to be present in field 18. The PBN subfield contains the RNAV or RNP certifications and operational approval applicable for the flight. So if you're putting in 10A, if you're putting this code R, this PBN details should be given in position 18. That is the other service information. In that position, you need to explain what type of PBN is used, and the certification number or the certificates number should be mentioned along with it. Second, tactical air navigation. The navigation system in UHF giving the aircrew continuous information as to its range and bearing from a beacon primarily used by military aircraft. I think tactical air navigation is well known that it's used for military purposes. So if the code goes as M, that is the type of aviation type of aircraft goes as M, then TACAN will be applicable over there. So this is another one which will be on board the aircraft, same radio telephonic frequency, but with a more high frequency range. This is same very high frequency. We have ultra high frequency and very high frequency. Next one, RVSM approved. This is the reduced vertical separation minima of 300 meter separation between aircraft. As I said to you that when an aircraft moves in one direction, both horizontal wise and vertical wise, you need a minimum separation. That is, it should be either 1,000 feet or maybe 2,000 feet. So some of them take as feet as consideration, while the others take it as meters. So it's either 300 meters or 600 meters. Now RVSM provides 6 additional cruising levels between FL290 and FL410. FL290 and FL410, resulting in substantial reduction in fuel cost and in-flight delays. So the main purpose to take a height of FL290 and 410. So before we go to the height, can anyone tell me how much height is this? What does FL290 means? Guys, what is FL290? Anyone know to? What is FL290 means?
Flight level 2,000 feet for 2,000 more.
So flight level is correct, and 290 means not 2,000. It will be 29,000 feet. So FL290 means 29,000 feet, and FL410 is 41,000 feet. So the main reason of giving this RVSM, this 6 additional cruising levels between FL290 and FL410, the reason these aircrafts are given these heights is to reduce the fuel cost. That is, the aircraft which is traveling at a very high altitude will have very less burn of oxygen. That is, oxygen content is very low in that height. 29,000 feet from the ground will have very low oxygen content, and the fuel, as you all know, the engine needs the fuel burning will increase as the level of oxygen increase. So due to that condition, flying at 29,000 feet will reduce the fuel burning, and the aircraft already has attained that momentum speed, and which will push the aircraft more. So with the minimum amount of fuel, the aircraft can travel longer distance. So that's the main reason for all the aircraft. If you check out all the ATC towers or any, if you when you work in your airport, you can go through this point that all the aircraft before pushback they'll request an early release of aircraft. The reason is they want the highest altitude. So for that purpose, they'll request the ground staffs to release the flight as early as possible. So that's about the RVSM approach. Then we have the MNPS approach, Minimum Navigation Performance Specification. So these are a set of standards which require aircraft to have a minimum navigation performance capability in order to operate in MNPS designated airspace. So all these approved ones will have a designated airspace, just like the first one I said. We also had a FIS statement, Flight Information Service, where in a particular flight information region, that service could be brought into action. So the airspace vertically defined between FL285 and FL410. So somewhere close to 20,500 to 29,000. And horizontal includes the following control areas: Reykjavik, Shanvik, Gander, and Santa Maria Oceanic Plus. The portion of New York Oceanic, which is north of 27, but excluding the area which is west of 60 degree west and south of 30. So this control areas that they have given is either water-based. So since it's New York side, it would be most probably water-based standards. And when the aircraft move through these water levels, they'll have this towers connection, and it's just a beacon light. It has a system to receive, scan, and resend it back to the origin. So when these beacon lights in the ocean side is installed, they are installed with such information. So if you are sending a message to the ATC regarding a flight plan change, all these details will be automatically sent from the ATC tower to the satellites and to all these beacons. So once the beacons will receive this message, when the aircraft is flying over that particular beacon and sending message and requesting it back, it will get an idea of what is the height level it should maintain, and what is the distance of speed it should maintain, and how many other aircrafts are also are also traveling with that particular aircraft in that particular direction, or maybe in the opposite direction. So these approved when this MNPS comes into action, their designated airspace will have such surface area or maybe a water-based beacon lights who will help them in their travel. Next, VHF with spacing capability. So very high frequency with 8.33 kilohertz spacing channel. That's all the difference. Next, we have other equipment. So what's other equipments indicates that other equipment or capabilities which are not specified in the item apply to the flight. These additional equipment or capabilities shall be specified in item 18, preceded by COM, navigational, or data. So other equipment, if something new is come or not from these commonly used equipments, any other special equipment is coming. So these, along with this COM / there is COM public stroke, and then you have to put in the details of the equipment that's being used. So very few equipments is the one that we hold. In this you can see so in this flight plan you can see that we have finished up the equipment side. Next we have the departure aerodrome. So departure aerodrome is the station from where the aircraft is starting its journey. as you all know that flight plan, international flight plan, only ICAO codes will be used. So the departure aerodrome will be a 4-letter code. The time is a 4-digit UTC time. Then we'll have the cruising speed. So your cruising speed will be calculated in knots, KL. So 1 knot is 1 nautical mile per hour, and that will be calculated. So if you take a standard 320 aircraft, you will have a speed of 350 or 380 knots. Flight level is FL 250 or 300 or 400 or 410. So based on the flight levels, you will be calculated a route. So you will be having a couple of water beacons, maybe water-based beacons. You may have land-based beacons, or you may be having an ATC tower to have a contact. So all those details will be written in capital letters with a small space in between, and we'll give the difference based on that. So this is an old flight plan. This it's from Etihad Airways, ETD 0273. So Etihad Airways, we need not be the dispatcher for those flights. They have their own dispatcher team in Abu Dhabi, and we as a half load controller and half flight dispatcher, we are given the authorized to collect these flight plans and submit it to the captain. The remaining will be handled by the captain. So being we only send the zero fuel rate, coordination, a flight dispatcher coordination work will be done for airlines other than Air India and Air India Express. So this is an Etihad flight line. Comparatively with the other flight line, I think this was a little bit much more easy to explain. So first we have the ATC CS. So this is the call sign. ATC call sign will be ETD 273. You can see that, right? ATC C/S. That's a call sign, ETD 273. Then we have the date, 4th March 2021. We'll have the operational flight plan number 6. So the final flight plan that will be issued to us, you need to confirm whether what flight plan it is. As a flight dispatcher, you will be the one creating this flight plan. But when you're being only just a coordinator, you need to know what is the flight plan that they have issued, the latest flight plan, because captain will get it digital, will get these flight plans digitally. We are the ones who will take the printout and hand it over to the captain. Now, to be very frank, most of the captains expect us to save paper, and they'll say that I don't need any printouts. Just give me some document that you need to file. You bring those documents for me to sign. So OFP will be 6, and the issue time is 1532 Zulu. So 1532 Zulu, all times will be in Zulu. And when you convert it into local time, you're converting it into Indian local time, you need to add another 530. So that will be 2102 local time. Next, we have Trivandrum International to Abu Dhabi International. The 4 ICAO code will be VOTV, and the IATA code is TRB. Abu Dhabi, OMAA, and the IATA code will be AUH. Standard departure of time 2110 Zulu, and its arrival will be 0135 Zulu. So this will be standard one. Next, we have the ETOPS. The flight plan is completely ETOPS. That is, it will be moving to the oceanic airspace immediately after takeoff. So if ETOPS comes up, understand that the aircraft will go for an immediate release of, that is, it will travel more time over the oceanic airspace. Now here we have some of the ground distance, the air distance, the average wind, average wing sweep, what is the pressure, and what is the average pressures, how much will be the fuel bias. So fuel bias is not required. We won't be looking into this P04.3. That will be given by the fueling agent. What is the standard bias of that? This I think is a 321 aircraft, so this will be a standard 4.3. If you go for a 320 flight, it may be somewhere around 2.5 or 3. So this fuel bias will be given by the fueling agent. The remaining you will be taking it from the weather report, and this is the first OFP. You can see the dispatcher's name, his number. So all the basic details that a captain needs will be put into this first page. The remaining details will follow, but what the captain needs to know, what are the basic things he needs to know, all those details will be put here. Now you can see the aircraft registration Alpha 6 Alpha EG. A6AEG. It's a Airbus 321 flight, 231 registration. MS9, that is manufacturer's serial number, will be 6731, and it will have an engine of IAE V2533 with sharklets. That is, these wings will have a blade, a pointed blade facing vertically up. So those are called sharklets. Now maximum takeoff weight will be 93. Landing weight 77.8 and maximum zero fuel weight is 73.8. So as I said to you earlier, when you for a flight plan to be created, you need, the first thing is a zero fuel weight. So based on that zero fuel weight, so the zero fuel weight given was 69.3. 69.3 is the estimate zero fuel weight that's given, and then the team starts planning it out. What is the route? How will be the exit route? Everything. So in this route, weather program is 0421, 0500, 0503, and OAS 0406. That is, it's all normal, based in the origin station. That is from Trivandrum to Abu Dhabi, and in Trivandrum, all your weather will be normal. If there is any special, if there is anything special they need to add, they'll put it as a supplementary information. So in this, these are just codes that captain will type into the aircraft system to understand what is the current status and how to see the weather report. I'll show you what the weather report will look. This is the satellite image. So in India, as you can see, Trivandrum will be falling in this sector. The full areas, you don't have enough clouds. The weather is normal. There is no problem with the traveling or no changes in the weather conditions over the sea also. So you will have like these weather reports coming from the meteorological side. So based on this weather report, you can plan what kind of route the aircraft needs to travel. Next is the route map. So how you will come into this conclusion when you open up the aeronautical chart. For example, if you're taking an aeronautical chart from Trivandrum or Chennai, and you need to go all the way to Dubai, so you will have a list of towers that come into that particular sector. That is anything between UAE and India. All the details regarding the towers, that is ground-based towers, ATC towers, sea-based towers, all these details will be there. And based on that, you need to find out which beacon towers will you be connecting to reach your destination. So in this, you can see that VOTV 32, Trivandrum's 4-letter code, and 32 is the runway distance. That is from which side the aircraft will take off. So I said, I think I had taken a session about the runways, these runway number. So 32 means what? What is the angle of the runway? What is the angle of the runway? Which direction is it facing? Just give me the number. I don't need northeast, southeast, nothing like that. Just give me the number. What is the angle the runway is standing?
Nobody knows the answer?
They know. I think they know.
They're thinking or they do not know the answer?
I think they know the answer. Come on, guys. You know the answers. All you need is to say it. Come on, go ahead. No problem. If it goes wrong, also it's okay. I had made a blunder of mistakes in my work also, so I will not
Shubham,
blame.
Mahir, Diksha, Raja, Pratik, can anybody try?
That's 32° north, I guess.
32° north. 32°, no. Actually, it's not 32°. It's 320°. So VOTV is 320°. So the opposite side, that is, this is actually a runway. Trivandrum has a runway called 1432. That is, one side will be 14 and the other side will be 32.
Actually, sir, everybody else in the other lectures, they switch on their camera here and we don't know they're awake or sleeping. Ask them also to turn on the camera. Then we will know whether they're all sleeping or they're awake.
Oh, no one's turned on the camera.
Audio on and yeah, so when sir is camera on, you all should also keep the camera on.
Guys, keep your camera on.
Yes. Yes. Now we know you're not sleeping.
Okay. Okay, that's good. So, so the VOTV 32 means the runway side, so which direction the aircraft has decided to take off. And then we'll have NUCET. So from Indian side, NUCET is an airway where you will initiate the ETOPS movement. That is, the aircraft starts its ETOPS journey. Since this is an ETOPS flight, you can see it over here in the top right corner. It's given as ETOPS. So since it's a 321 flight, you will have minimum 2 to 3 hours of ETOPS journey. That is 120 or 180 minutes ETOPS journey. So from Trivandrum itself, it's straight away going to NUCET. NUCET is the airway which will be starting of the ETOPS journey. We have NUCET, SAPCO. After SAPCO, you will see a couple of codes. V21, something says that you have to catch the Victory 29 runway. Then DOTAT gives another tower. Then you will have a P570. That is the airway facing to the, that is Papa Airways. We call that as Papa Airways. That in the height of 570. The position will be 570. So I'll tell you how you will put these codes. Then each 5-letter codes will be the beacons that you will be handling, and the letter and the 3-letter number is the airways the aircraft will be taking. So this will change according to the height. As you can see that we have N563 and N563 over here. So these two are of the same height. You will be going at least a little bit up before you prepare the aircraft for landing. Nopto, then we have Abu Dhabi 13 Romeo. So 13 Romeo is the direction in which the aircraft is decided to land. So that is 130°, and R represents the right side. Abu Dhabi has total of 3 runways, and in that the right runway 13 Romeo direction the aircraft will land. Departure ATC clearance not required. Departure ATIS, that is in case Air Traffic Information Center, if you need to contact them, they have given their frequency. This will be used by the captain through the CPDLC. That is Commander Pilot Data Link Communicator. Using that, they'll type this frequency. They'll type this frequency and communicate with it. Here we have another thing, ground company and frequency. So these are the 4 main frequency that is being given to them in case of any emergency. One is the Air India Sats. They have a frequency of 137. Etihad Flight Dispatch Team 124.950. Etihad HCC NOC 129.975. Etihad MCC 127.7. So in the CPDLC, if they set these frequency, they can contact with one of the team members. So in Air India Sats, normally I will be the one who will be sitting here. 137.0. We'll be using this frequency for in case captain needs any help. But these frequency is not used because we mostly stand right beside the captain discussing about the flight plan. If he requires any change, we'll be right beside him to confirm the information. Next, plan fuel. We have fuel, the airport, total fuel that you are going to take, and what is the time for each fuel. Here in this trip, that is to Abu Dhabi, your total trip will be 11,327 kgs, and your trip time is 3 hours and 52 minutes. On an average basis, from Trivandrum to Abu Dhabi takes about 4 hours. So based on the plan, that is the route map, you will have a change in the time, maybe say 8 or 10 minutes. Or if there is an extra change of weather and you have a tailwind of aircraft, this 352 will also in 3 hours or maybe 2 hours 52 minutes. So that's based on the report that you collect from the meteorology department. You have a contingency of 3%, so 340 kgs of fuel, and the emergency partition, an extra of 898. We are sending go to your alternate station. That will be mostly, I think, Oman is somewhere in Oman. So based on that station, you have about 900 kgs of alternate fuel. Then FINDRES 1364. That FINDRES means the remaining fuel. You just need to know how much extra fuel that you are holding in case you need an extra. We say that as ballast fuel. Here it's given as FINDRES. That is 1364, and you have 30 minutes of ballast extra. ETOPS not required, 0 fuel and 0 time. That is, both the captains have been trained for ETOPS and nothing extra fuel has been shared. That is, you need not use extra fuel for ETOPS in case the engine is running on, in case the aircraft is running on single engine over the oceanic airspace. Planned takeoff fuel 3929, total will be 4 hours 46 minutes. Additional fuel, nothing is required, so takeoff will be 3929. Taxi in airport BOTV will be 235 kgs. So the distance from the terminal side to the aircraft takeoff point will be to something where we will burn about 235 kgs. That is 15 minutes of taxi time. Block fuel will be 40,200. So this will be the plan that's given by the dispatcher, and captain can. It's been instructed that captain will be taking 14,200 as their minimum fuel. So if you want to increase the fuel, he can increase it and just put a report of how many fuel he is going to start the engine. And he has another section over here that is in page number 11, I suppose. Yes, the dispatch briefing info. He can put any additional information over here, informing the team that he has taken extra fuel for so purposes. That's the fuel side. Next, we have dispatcher remarks. Here is the operational impacts. So this operational impacts will be weight up by 2.0, weight up by 1.0, weight down by 1.0, weight down by 2.0. So as I said earlier, if a zero fuel weight has a change, if it's within 500 kgs or maybe 200 kgs, 350 kgs, you just need to inform the captain. Captain, we have a change of 350 kgs. What should I do? So either the captain will say that you put something extra on that fuel. I'll put another 20 or 30 kgs of fuel extra. But a flight plan will have, for a narrow body flight plan will have an up and down of 2000 or 2500 kgs. So the flight plan, the zero fuel weight should not change from 69.3, and it should not have a drop of 2.5 or an increase of 2.5. So if it's going somewhere above 2500, saying you have to offload the entire cargo, the dispatcher says that sorry, we can't do anything. You need to offload the entire cargo, and you're offloading something around 2500 kgs or 3000 kgs of cargo. This zero fuel weight will change. So from 69.3 it goes straight to 66.3. if it is in 66.3, the captain cannot use this fuel plan for his troop. So if he can use this fuel plan, then the dispatcher has no other choice. He need to go and change the entire flight plan. He'll be changing the route. He needs to check how much fuel will be consumed for that particular route, and is any other aircraft traveling at high priority is going in that direction. So there is a lots of problems that will come if you're changing a flight plan, say about 1 hour or 2 hours before departure. When you change those flight plan, it's very hard for the this new flight plan aircraft to get the highest flight level. So in this flight, I think accurate fuel weight of 69.0. Here they have shown the difference. If the weight is done up to 2000 kgs, the trim will increase to 247 kgs. And 247 kgs. Weight up by 1000 kgs, you need to plus 127. So this P stands for plus and minus. So if you add 100 kg, if the weight go by 1000 kgs, you need to add about 100 kgs of extra fuel to the trip set. This will be adding 100 kgs. So if drop off 1000 kg, you need to add about 190 kgs. That is meaning the fuel consumption. So to only up to kgs for the for 320. Normal 320 is 2005. I think is some restrictions on it. Plus, up to 2012. Then FL up by FL flight level 1 or down by FL flight level 1, still in the fuel. The flight has to be increased with such amount. So why are you increasing the trip fuel when a flight level is decreased? Why is the flight level when the flight level is decreased, that is down by 10,000 feet, they seem to add another 212 kgs to the trip fuel? Why is it? A flight level, if you're going down by, if it's going by another 10,000 feet, that's okay. But when the flight level is dropped, you need to increase the trip fuel by 212 or 426 kgs. Why is it that? No idea. Anyone? Come on. It's right or wrong. That's not a problem. When the flight level is increased by 10,000 feet, that is decreased by 10,000 feet, you have an increase in fuel, 212 kgs. Why is it there? No one on that side? Okay, that's okay. The flight level, if you are decreasing it by 10,000 feet, you know that any flight level that's traveling more than 29,000 feet will have less fuel consumption. So if the aircraft, for example, is flying at 30,000 feet and you're dropping down another 10,000 feet for the flight will be traveling 20,000 feet, which will consume large amount of fuel. So for that, you need to put an additional 212 kgs so that the trip fuel doesn't get burnt out. That is, it doesn't finishes up by the time they reaches the destination. For that purpose, in case if there's any drop, they plan it early and increase the fuel. So it's 14,200 and captain might write as 40,500 kgs. That will be the final fuel. Yes, go ahead.
So I didn't understand. Please, will you repeat that question? Will you repeat that explanation?
Yeah, sure. So you can see here is FL, D, and FL1. Can you see that?
Yes,
so
sir.
Flight level down by FL1. FL1 means it's about 10,000 feet. So FL1 is 10,000 feet. If the flight's height, for example, if they're planning a flight level of 30,000 feet and you're dropping down 10,000 feet due to some any other issues, due to some weather changes, you're dropping the flight level by from 30,000 to 20,000 feet. The fuel consumption of the aircraft will be very high, because if it's going more than 29,000 feet, the oxygen content will be very less in the atmosphere. So when the aircraft moves, it can go in its own momentum and it need not burn so much of fuel. But since it's dropped down 29,000 feet and it's flying at a height of 20,000 feet, we need extra amount of fuel for the aircraft, because with these 11,327 kgs, you might not be able to reach Abu Dhabi safely. So for that, they have calculated and added up this portion, 212 kgs extra. So when you add that, it's about 540, I suppose. Yes. So 11,540 kgs of fuel should be on board. Otherwise, it won't reach Abu Dhabi with a flight level of 20,000 feet. Is it clear?
Yes, sir.
Okay. So that's for the OFP. So this will be the document that flight dispatcher will be filing. So captain will write the final fuel over here beside the 12 total fuel. He'll put his pilot license code. Then actual fuel on board at engine start. So once the aircraft pushes back and it starts the engine for takeoff, I mean for the taxi, the actual fuel will be written here. So this will pilot's copy, or we'll take another additional copy same way. We'll give one copy to the captain and the other one to us. So this will be the report that captain will be writing. What is the fuel at the engine start point? He'll put a sign and he will file this copy to in the headquarters. That is the other in Abu Dhabi. He'll be filing this. Next, in the second page, you can see the alternate routes. So what are alternate routes we have? You guys can see these codes. These four are the four airports. So here we have 4 alternate airport routes. So the first one will be Al Ain Airport. We have Dubai Airport. We have DWC, that is Dubai World Central. I think it's Al Maktoum International Airport. Then we have OMSJ, that is the Sharjah Airport. So these will be the 4 alternative airports from Abu Dhabi. That is very close contact, and they will be planning their route. How will they reach this particular location, and which runway will they be using? What is the flight level they need to approach when they are in Dubai? What is the flight level they need to approach in DWC or Sharjah? So the flight levels will be given. WC, weather change, any weather change, +6, +6, +7, +7. Since it's in the same country, not much of a change in that. Time of travel, 17 minutes. Time of travel, 30 minutes, 38 minutes, or 39 minutes. Fuel required, about say about 90 or 900, not 900 kgs, something around 900 kgs. Here we will be requiring 1.5 tons. Then we'll have 1.9 tons, 1.9 tons. So the actual fine thrust fuel they have given us 1.4. So the captain, in case if they need an alternate fuel, they should save the amount of fuel early enough. They'll go through all these pages before they fill up the final total fuel. They need to know what are the alternates, what are the changes they are going to do in the alternates. Will they be using this alternate area? So in the Spindles, it's 1,364, that is 1.4 tons. Captain needs an alternate fuel of something close to 1.9. In case if there's bad weather in Abu Dhabi, the aircraft, if it couldn't land in Al Ain or Dubai or DWC, it needs to go to Sharjah. So in that case, he need an extra about 500 kgs more fuel. So he might add this in this fuel. 14,200 may become 15,000. So captain will go through all these points, the alternate points, and here we have a remark also. Please, Akash, dispatch 60 minutes before ETD, departure runway defense from plan to update OFP. In case if it's not VOTV 32 and the aircraft is departing from VOTV 14, at least 60 minutes before they need to update it so that it can be informed to the ATC tower with a new flight plan. So what will be the ATC? I'll show you what will be the ATC flight plan. Here you go. This will be the ATC flight plan. So the format I showed you, the international flight plan. So that will be having these codes. Here we have the FF, the addresses, POTV, ZP, ZX. So such codes will be there. These are all the addresses. Then we will have FPL, ETD273 normal. We have IS. So anyone can tell me what is this IS stands for? What is I and what is S?
Indian Standard Time.
Actually, no. The FPL ETD, I will be standing for Instrument Flight Rules, the IFR. So I will be for IFR and S will be the standard communication. That is, communication and navigational of this aircraft is standard. It is having all the basic requirements to fly to an ETOP sector. Next, we'll be having A321, and this will be the aircraft code. Then we have LB1D1. This is a part of the Air321, that is what code it has been authorized. Either the Etihad Airways will be authorizing, or in case if it's any general aviation, or say if it's something other than the commercial airlines, their special code will be given. Next, we have VOTV 2110, departure aerodrome and the time. We'll have what is the direction of travel, the flight. Flight level will be F340, that is 34,000 feet. It's been planning. The route map, Nuket, Sabko, all the way up to Nokto. The arrival time of the 052. In case our first alternate will be OMAR. PBN, I had given you a lecture about that today. So PBN is the equipment they have used here and their details. So it's part of the standard. So PBN will be given with a particular code. That same thing, CPDCX 260 Bravo will be the extra other information in case of reference. Date of flight, it will be on the same date. Timing is this, and this will be the date 210304. So here what they have planned is our departure time is 2110, and in the ATC plan they have been informed that the flight will release early. So in the departure flight plan, it's given that the aircraft will depart by 2103. That is, the informing ATC will release 7 minutes earlier. Registration is given, EET, total time, each location, what will be the time before they land. So all the details will be given in this, and this is the one that will be sent to the ATC. So in this here we have the YAC number. So this is the code that DGCA have been giving them authorization. This code should be mentioned in the ATC plan. Otherwise, the captain or the ATC tower will not have any idea about it. So first will be the alternate locations and their respective fuel amount, whatever it is, that will be mentioned in the second page, and in the third we'll have the elevation difference. So these details will be filled up by the captains. How much elevation feet reference will be given, what will be the performance data, and all these information will be filled up by the captain. What is the flag position, the point of runway start, the takeoff point, and which angle. So these are V1, VR, V2. This is for landing side, which runway, international, what is the shift, dry wet condition, whatever it is. So these informations all are filled up by the captains. Next, it's given the actual time. So off block, we have planned for 2110 Zulu. So captain will be putting what is the actual time of their departure, what time they have takeoff, what time they have landed, and what's the chocks in time, that is the aircraft reached the bay. Then block time, schedule is 4 hours 25 minutes, estimate is 4 hours 12 minutes. How many time did they actually take for the travel? So these information is given in page 3. In page 4, we have the destination log. So in page 4, we have the flight destination log. This flight destination log will have what airway they are using and what is the waypoint. So airway they are using is Nuket, 31,000 feet. It is 319. That is which direction it's going. What is the max speed or IAS point? Then what is the distance of their travel? How many minutes they will be traveling? What is the total fuel they have on board? So in this you can see that 1676 is the date. No changes. Only 200 kgs of fuel have been burned. Then we have 14,000 kg on board the estimate fuel on board. Once the aircraft takes off, it takes about 600 more, and now the estimate is 13.6. So in this manner, the calculation will be done. The calculations will be done, and this 900 kgs of fuel from the next point, and the remaining is 13.3. By the time they reach Sapco, it will be 12.8. That's another 1,500 fuel. So this will be keep on reducing until they reaches their destination. And by the time they reach Abu Dhabi, the fuel on board will be 2.7. That is 2,700 kgs extra fuel. Destination ATIS, that is air traffic service, they are given command 119.975. So this detail you have to give for each position, that is each distance of their where the next ATC is coming. So their distance, how much fuel will be burned, what is the aircraft performance rate, all this will be calculated, and you will have to put these estimated fuel time till they reach there. That's up to page 6. Then in page 7, we'll have the ETOPS alternate fuel requirements. So this is ETOPS information. As I showed you, it will be either 120 or 180. In this, they have put a roll time of 120 minutes. Here we have a time that is 1 hour 38 minutes or 1 hour 23 minutes. 570 or 460, that is 570 ground distance or maybe 460 ground distance. So these will be calculated in kilometers, and the flight level 100 flight level. That is approximately 20,000 feet. So estimated fuel on board will be 8.1. Here it will be 6.1. Chance of burning 6.8, 5.9. So we have two ETOPS performance rate. So either one of them will be performed, and whichever is being performed, that will be reported in the flight information, that is in page number 2. Weather, forecast weather, it is 10,000 to 4,000. That is normal weather. Crosswinding is 3 knots. So 3 knots is not much of a problem. If it has increased, say about 6 to 10 knots, then you will have problem for landing, and the aircraft either have to go for alternate station or it will perform a crosswind landing. So crosswind landing, that decisions will be taken by the captain. As far as dispatcher's role, we will be requesting the captain to we will be giving the flight dispatcher on basis of the alternate station. Next, we will have a destination alternate flight log. This will be also the same one. The distance it will be traveling. The distance from the total, that is 11.6, 11,600. We have planned only for 11,540. So here they have taken an average of 11.6. So the fuel from the for the entire trip all the way up to the Abu Dhabi station, or if it's going to the next alternate station, it needs something around 11.6 fuel. So in case if it's landing in Align, 2.7, the remaining fuel will be only up to 1.7. So this will be the alternate log based on which you need to plan in case if you have more wind or if there's any problem with the weather. You need to plan this alternate flight log along with the flight plan list, so that captains will not have any problem at the time. In case if the weather goes bad, he needs to go and check out whether the alternate flight route is put, whether you are expecting something like that. So this is another condition in waypoint. Climb winds 350,000 feet, 104, 023 -4. So while you're climbing, the direction of your climb and the waypoint coordinates. So based on that climb waypoints, you can see that from VOTV you will have an angle north 828.8 and east will be 7655.2. So these are the informations that you will be feeding into the aircraft. Latitude and longitudinal distance. So based on that, you will have the correct point where the exact points will be. So 828.8 and 7655.2. So this, when entered into the aircraft will identify the exact point. It has an inbuilt GPS system, so it won't be having any problem finding the exact location. Cruise winds also, they have given flight level 300, 30,000 feet, or 32,000, 34,000, 36,000. So they are being planned up to 36,000 feet. This is the entire flight route that they are going, that is including the waypoint coordinates all the way up to their destination. Then we have the ATC flight plan. Now is the weather report. So from page number 12, the first 11 pages is the most important. Captain will go through this. The remaining will be the weather reports, NOTAMs. This will be something around like somewhere close to departure. So this was released say about 9 o'clock in local time. Yeah, 1725 UTC, and the aircraft departure is say about 4 or 5 hours later. So it's just quite early, but it will have the latest report in case if there's a change in the weather. There will be a flight plan. There will be an entire flight plan change. You need to change all the flight plan details, including the route map. Here we have the from Abu Dhabi, what are all the current situations, the flight level, what is the north speed, in case is there any weather issues. So this information will be given by the weather report. That is, in this case, it's Lido Weather Service who have produced this report, and this is only for the captain's reference to know what is the condition of the aircraft. In most of the situations, the captains need not by heart all these things. It's just a code format, a message format, and they'll enter this into the aircraft to know what is the actual outcome or how the aircraft extra fuel will be affected. So all this will be done in the Airbus. In Airbus, that is not a problem. It can auto read all these messages, and the aircraft can itself come to a conclusion. Not only that, the aircraft has a capability to self-balance itself during the process. So if the aircraft is fully loaded, the load sheeter need not go and give the captain the load sheet. The captain can himself put the aircraft into self-balance mode to understand what is the estimate trim that he need to adjust for the aircraft to go safe. And some captains do that reference, even though when we give the load sheet, you give the load sheet and the captain checks it. Oh yes, the aircraft also gave me the same amount of trim. You are okay to go. So few captains do the cross-checking, but most of the captains trust the load control to give the trim and inform us if there is any change required or not. This is the weather report. Now there is en route airport. So all the airports en route their way to Abu Dhabi, all their weather reports will be also mentioned in this. Here we have Cochin, Calicut, Bangladesh, Abu Dhabi, Doha, we have Karachi, Trivandrum. So all these en route, how many and all cities are there? If there is any change in the weather or if there is any other conditions, all this will be put into this flight plan for reference. Next will be the NOTAM, that is a notification to airmen. If there is any extra information that should be given to the captains from the weather side or the DGCA side or through any other, that is other than the flight related things, so that will be put here. In this, there is nothing special information that is given, just an OIP number, their route from to where, what are the alternate sectors, and the ATC plan route. Departure airports, only aircraft up to code C type landing on runway 14. So these are the information that's given for Trivandrum sector. In case the aircraft is, since the aircraft is coming into Trivandrum, all these information regarding Trivandrum station will be kept here, just for captain's reference. In the case of there is Abu Dhabi airport, that is the destination airport. You can see that AIP supplement Abu Dhabi International runway 13L or 31R downgraded to category 1 operation. So that is the reason why the flight has been decided to land in 13 Romeo. That is not on the left-hand side of the 13 side, the right one. So it has been downgraded to category 1, category I operations. Category I is for medium range or not heavy aircraft, but much lower side. So for those aircraft, it has been downgraded as part of their safety measures. So due to that reason, the current aircraft has been allotted to land in 13 Romeo. Then we have the company NOTAM, destination, alternate destination, any NOTAMs are informed, that information is also put into this. So what and all stations, all the alternate stations, weather report, their NOTAMs, all the information will be put into this. This will be informing captain regarding, in case if anything goes wrong, the captain needs a solution out. So all the flight plans will be in a standard site with all the NOTAMs and NOTAMs, company NOTAMs, airport NOTAMs, all this will be put into this. Crew bulletins. So once after this end of Lido company NOTAM bulletin, so once this NOTAM bulletin finishes, then comes is the route map. So what is the route map? What is the direction of their drawings? Which and all stations they have been taken? So all these informations, they'll be drawing it in this. We have the aeronautical chart. We have 2 exit stations where the that is based on Bombay. BABB is Mumbai. So their last contact will be at this point. That is this much distance from entry to exit will be the contact range of the aircraft in ETOPS. So even though the aircraft start from Trivandrum, their entry to the ETOPS section will be from this point. That is PLDC, and then we have PTDC, that is the exit center. Here we have the towers required for the travel. So from Trivandrum they'll first have contact with DOTAT, then Bowman, Orlink, Otabi, Nibud, Netib, Latib. So these names with their codes will be given all the way from Trivandrum to Abu Dhabi with a flight level. You can see here flight level 250 to 630. So valid till 5th March. That is 5th March, 12 o'clock. As per UTC time, 5th March, 12 o'clock, this flight plan will be used. That is the aircraft, if it didn't depart from Trivandrum by 5th March midnight at 12, this flight plan must be entirely changed. So in case if there's a change, if the flight level is from 100 to 450, you will have another change in the directions. Here's the weather report that will be that you will be receiving, and that is India side. Then this is only plain about India, and here we have towards the eastern side, Australian eastern side. What is the total flow of weather? Completely related to UAE, that is the destination weather. And what are the flow? How many flights are flying in that area? What is the traffic level? All this will be informed. This is the complete meteorological group. They'll be sending in the weather reports from India to UAE. Is there any problem? The flight levels and what is the temperature or any wind or extra clouds formed. So it's clear that from India to UAE there won't be any clouds at this moment. The aircraft is free to fly. Towards the eastern side, yes, heavy cloud formation, chances of jerk or there is aircraft will face some turbulence. There is a chance for turbulence if it's going towards the eastern side. UAE normal. Towards the northern side, we have a few turbulence charts. Now, this is the vertical flight profile. So the aircraft starts from POTV, the height level it reaches, then up to the profile. Here they have been saying about a height level of 350,000 feet. The pressure will be somewhere close to 250. So 35,000 feet, 35,000 or 33,000 or 35,000. Somewhere close to that, the flight will be traveling all the way up to Abu Dhabi. So this will be the airline's movement. What is about the aeronautical chart? 1 second. This is the aeronautical chart based on which you will be planning your route map to a particular sector. So in this, I have taken the aeronautical chart of Mumbai. Here you can see that each location, that is the angle at which the aircraft have to move, what direction they have to take, what is the distance of each towers, how much area the towers will be covering. So all these information is given in this aeronautical chart. This is actually open for public, so you guys can take a look. Just type aircraft and maps. You will get an idea of how these plans are going on. So how the towers area will be confirmed. What are the towers that's been operating in Mumbai? How many towers you will get? So all these things are in the website. So when we are doing the practical side, that is when we are manually drawing these lines or pinpointing a particular towers and all, you will get a clear idea of how these aeronautical charts. I'll show you how it will be done. So we need to do a manual class, that is an offline class, to do all these.